Here we have a worksheet from City University, and I will use the SIMPLEX method to solve this problem of linear programming. So I have three variables, x1, x2 and x3, such that 4x1 plus 3x2 plus 3x3 is less or equal than 12. Then I have 3x1 plus 4x2 plus 4x3 less than 12, and again x3 less or equal than 1. Now I want to find the maximum value of the objective function. That's the objective function, so I want to find the values of x1, x2, x3 that make the objective function maximum using the simplex method. So we will analyze here the simplex method. The first thing to do is to turn inequalities into equalities. How it's done? Now we take the first one, 4x1 plus 3x2 plus 3x3, and we add a new variable that's called slack variable s1. Now this variable here covers the difference between this sum and 12. So I add something to that and I'm taking 12. Of course s1 must be non-negative. I'm doing the same for the second relation here. So 3x1 plus 4x2 plus 4x3 plus I will introduce a new slack variable here, s2 equals to 12. And for that one I have x3 plus a new variable here, s3, and it will be 1. Of course I have 0x1 and 0x2 and 1 times x3. Now I have introduced s1, s2 and s3. These are the slack variables, and I'm going to create the first table. So that's the first table of the simplex algorithm. Now I want to substitute the elements here. So here you have the basic variables. Here you have Cj, here you have Zj and delta Z. We'll see how we complete all these gaps here, all these blank spaces. So here is the x1 column, here is the x2, x3, here is s1, s2, s3, here is b, and here is b over a. Again we have Cj, here we have x1, x2, x3, s1, s2, s3, b and b over a. We will not need this one, no problem. So then we start to fill the gaps here for the first row and here I will have the coefficients of the objective function. So this is my objective function. The coefficient of x1 is 2, so I complete 2 here, 2 for x2, 3 for x3, 0 for s1, since it could be written like 0 s1 plus 0 s2 plus 0 s3. So 0 and 0 and 0 for this here. Now I write down the coefficients here, you see. So the coefficients of the first constraint, I have three constraints that were transformed into equalities. So this is 4, and the other coefficient is 3 and 3, and here for x1 is 4, then 3, we don't write something here, so 4, 3, then 3, then for S1 I have 1 because the coefficient here is 1, S2 0, S3 0 since I don't have S2 and S3 here, and here I'm writing the right part of the equalities, so 12. That's how I completed the first row. Then we are going to the second row. I complete in the same way, and I have 3, 4, 4, then 0, 1, 0, and the coefficient here, that's 12. And for the third row I have 0, 0, 1, 0, 0, 1, and 1. Now it needs to be careful here because we see that here we have a matrix. This one is called a flow matrix, and here we have the identity matrix. It's not random. We created that identity matrix. I need to have here an identity matrix, and I see that this unit corresponds to S1, so I'm writing here S1. This unit corresponds to S2, I'm writing here S2, and this to S3. So my basic variables, so the first variables that are going into this algorithm are S1, S2, and S3. Next to this I have 0, 0, and 0 because they are associated with a value of 0 since they are not real variables but they are slack variables. Now we continue to calculate Zj. How? For x1 the value here that I have to calculate is actually this product plus this product plus this product, so 0 plus 0 plus 0, and this is 0. For the second one is 3 times 0 plus 4 times 0 plus 0 times 0, again it's 0. For all of them also this is 0. Okay, then what's delta j? Delta j. For delta j I subtract from this, I subtract that. So from the corresponding coefficient of the objective function I subtract Zj, and I have 2 minus 0 is 2, 2 minus 0 is 2, 3 minus 0 is 3, 0 minus 0 is 0, and 0 and 0. Now the idea behind this algorithm, the simplex algorithm, is that for that row, for the last row, I must not have positive elements, because if I have positive elements, then I can substitute some basic variable here by some other variables such that the value of the objective function can be better, so I can have more value in the objective function. It means that if I see something positive here, the table is not sufficient, I have to take a second, maybe a third, maybe a fourth table, and I will stop if all the elements here are 0 or negative. But how do I create the second table, so the second table of the simplex method, from the first table? Okay, the first thing I'm looking at is the last row here. You see, in the last row I have 2, 2, and 3, and I'm taking the maximum positive number, and I denote that column here by an arrow. So I care about this column here because 3 is the maximum of the positive numbers of the last row. Now the next part is that you see b over a, so I have to divide b by the corresponding elements. A actually are the elements of this row here, and only these three elements actually. So 12 divided by 3 is 4, 12 divided by 4 is 3, and 1 divided by 1 is 1. So here we have the ratio, and there is a smallest number in that ratio. The smallest number is 1, and we denote that by an arrow that denotes that row, and here we have the arrow that denotes that column. At the intersection of these two we have 1. This one is actually the pivot element. So it's very important in how I create the second table here. So let's see the second table very carefully, because we have to see how we create now the second table from the first table. First of all, it means here that if I substitute the basic variable s3 by x3, then the value of the objective function can be optimized. So it means that I'm starting here again with basic variables, again with Cj doesn't change, Cj is always the same, they are the coefficients of the objective function. Here also we have b, I will call it d now, and we'll have d over a. Now what's important to understand is that in the place of s3 we will have x3. So s1 doesn't change, s1 will be here and the value will be 0, s2 will be here and the value will be 0, but in the place of s3 I will take the x3 and I will have x3 together with the corresponding value of the objective function for x3, that's 3. So next to x3 I will write 3. Now again we have x1, x2, x3, s1, s2 and s3. But now we have to be really careful, because here I have 1. If I didn't have 1, I should do some process to create 1 here, and the process has to do with the row operations that we use in the Gauss algorithm. So for now I substitute that by 0, 0, 1, 0, 0, 1. So